If you are a beginner and you ignoring information disclosure, then you are skipping the foundation of bug hunting. In this video, I'll break down the information disclosure from a bug hunter's perspective and solve all PortSwigger labs step by step. Now don't worry, this is not going to be a boring PortSwigger lab solving video. In this video, first of all, I'll discuss what is information disclosure and how you can find it in a better way. So make sure to watch the video till the end. Information disclosure is when a application accidentally reveals its sensitive internal details that attackers can use to understand and eventually compromise the system. These details can be the server's version, framework's names, database name, hidden endpoints, API keys, source code, or any error message that reveals some internal sensitive information. Now you might think this looks very small, just an error message, just a version header, but in bug bounty hunting, even small information leaks can be a valid reportable vulnerability. So now that we know that what information disclosure looks like and why it is dangerous, the real question is how to find it. Where to find all this sensitive information? If you are an absolute beginner and you don't have much knowledge about things like get version controller or HTTP headers, you can follow a simple principle that I call BCED to start finding information disclosure issues. Now what this BCED stands for? B stands for backup, C stands for comment or config file, E stands for error message, D stands for debug. Let's understand each of them one by one. The first one is backup files. Backup files may look like backup.zip or any .back or .old file. Sometimes developer accidentally leaves the backup files accessible on the server. From this you can access the backup files and find some sensitive credential inside it. Second one is comments or configuration files. Sometimes developer forget to remove the comments where some hidden information is provided, like some credential or notes left by developer. They forgot to remove this comment, so you can check the source code of each page to find this kind of information. Also, you can check the exposed configuration file like .env file. Sometimes you will find this kind of sensitive information exposed online like these configuration files. So you must search for them. Then the next one is error message. Error message can reveal sensitive information such as file path, database name, framework versions, and sometimes if error messages are not properly filtered and directly show to the user, then it can also reveal more internal sensitive information like how the website is working and about its other functionalities. Now the last one is debug files. Sometimes developer accidentally leaves debugging enabled in production, which may expose internal logic, server environment details, and others time you can find the debug file exposed publicly. This can help you to find the bugs. I hope you understand this BCED principle. This is a very simple and beginner friendly principle. So before you apply this BCED principle, it is helpful to first identify what technology the website is using. Once you know the tech stack, then you can search for backup files, configuration files, error messages, and debug information that are specific to that technology. For example, the configuration file that are used in Django is not similar to used in Node.js. Both are different stacks and both use different kind of file structure, different debug file, different configuration file. Make sure when you are using this BCED principle, you are finding files that are specific to a particular technology that is used by that particular website. Otherwise, you will find a whole day but get nothing. Once you move beyond this beginner stage, you can start looking at more advanced information disclosure vectors like exposed Git repositories, sensitive HTTP headers, API response, and misconfigured servers. That is enough about the theory part. Let's move to the PortSwigger and see how you can practically find the information disclosure vulnerability. Let's start the PortSwigger labs. Now there are total 5 PortSwigger labs, and the first 3 follow the BCDE principle that I previously told you, and the last 2 is a little bit advanced if you are an absolute beginner and don't know about how HTTP requests work, what is HTTP header, and what is Git version control. But don't worry, I'll try my best to explain these 2 last lab to you. The first lab is information disclosure in error messages. Comparing to the real world, here the labs are very much easy because it's already told you how you can find the vulnerability. Like here already mentioned that it is in the error message. So you have to find a error where you can get the flag and submit it. If you look at the flag description, it is telling that the lab's verbose error message reveals that it is using a vulnerable version of the third-party framework To solve the lab, obtain and submit the version number of this framework. So let's start the lab. As previously mentioned in the lab, we have to generate a error where you will get the version of this framework and we have to submit it. To generate a error, first of all, I'll try the 404 or page not found error. For that, I'll add a slash to the URL, then add a random path that don't exist in the website. It should be random so that it will throw a error. Now it throw a page not found error, but there is no other information available here, so we can't find the version here. We'll try some other functionality where we can find an error. For example, click on view details. It will show the product detail. But here if you look at the top, there is a product ID field which is taking the ID of the particular product and showing about its detail. Now here if we provide a value which is not valid, it will also generate a error. Instead of this number, I'll give a letter. And as you can see, it throw a error, and in the end it is showing the version of the framework it is using, which is Apache Struts. Now this is the version of it. Let's copy it, go back and submit the solution. In this type of cases, you have to try multiple values on different places so that you can generate any kind of error and get any information from out of that. Now we solved the first lab. Let's move to the second one. Information disclosure on debug page. Now in this lab, there is a debug page that discloses sensitive information about the application. To solve this lab, we have to obtain the secret key that is available in the debug page, then submit it. As I told you before, the location of the debug file may differ from stack to stack. Like in different frameworks, the debug file located are different locations. First of all, we'll start with the very basic. If that don't work, then we'll try some other methods. First and very popular method is go and find on the page source. We'll try to find any kind of information from the source page of the website. End of the page, there is a comment available where the debug page link is available, which is cgi-bin/phpinfo.php. Let's paste this. And here we successfully get the debug page of PHP, and we have to find the secret key here. This secret key, I'll copy it and find the secret key. Here is the secret key, copy it. And let's go back to home page. There I will submit the solution. Now in this scenario, we find the debug phase from the source code where it is commented already by the developer of this application. But in real world scenario, you may don't get it from the source page. Instead, you have to first of all check which stack it is using. After that, you have to check from this particular stack from where you can get the debug files. Then you have to go and search manually one by one of them. Then there is a high chance that you will find the debug page. This lab is also solved. Let's move to the next one. Source code disclosure via backup files. As its name considers, this lab is all about backup files. Now this lab leaks its source code backup files in hidden directory. To solve this lab, identify and submit the database password which is hard-coded in the leaked source code. So we have to find the backup folder, then identify and submit the database password. First of all, I'll check the source code. And here I don't find any comment or links that indicating to the backup page. No information available here. Now you may get help from the robots.txt file. Most of the website remove this robots.txt because this becomes very common nowadays. But this is not a real world website. This is just a lab, so we can find it. And as you can see from here, we get a folder /backup which is disallowed to crawl. Let's go to this path. And here is a backup file available. And this is a connection building command from the PostgreSQL. I guess the last one is the password. Go back to the home. and submit it. Okay, now it is solved. Now in our case, we find the path from the slash robot.txt. But in real world, most time we will go to the robots.txt. It is already removed from there. So you have to use other techniques like I already told you. These three are very simple labs, so we don't need burp suite for it. For the next one, we'll use the burp suite. Let's move to the next one. In the previous lab, we find different bugs that we are only submitting. They are like just normal error message or version of the text tag that is using. But in this lab, you'll see how we can bypass authentication using information disclosure. This is going to be a more powerful attack that you can perform using information disclosure. Now, in this lab, the administration's interface has an authentication bypass vulnerability, but it is impractical to exploit without the knowledge of HTTP header used by the frontend. Now, this is already mentioned that we have to use the HTTP header to bypass this authentication. To solve this lab, obtain the header name, then use it to bypass the lab's authentication, access the admin interface, and delete the user Carlos. You can log in using your own account using the following credential. And here are some credential provided using which you can log in. Let's copy it. Go to my account. Now I successfully logged into the home page. Our next task is finding the administration interface. After that, we'll see how we can bypass this. As this is a lab and not any real world website, you can find it very easily. Like the most very common name like administrator or admin panel. This kind of name represent to the administrator interface. So you can find it easily. First of all, we will use this word administrator. There is no path like this. The second one, we will try admin. Okay, we got the admin interface, but it is not available for the local user. Now let's start the burp suite and see how we can bypass this. I'll go to proxy, then turn on the interceptor, then send a request. Here we get our request. Let's send it to repeater. Now once the request is in repeater, we can check it and modify it, then send it to the host. I'll turn on the intruder. Now if you send this request now, then it will return us admin interface is not available. Let's see what are the headers it is using. All the header currently available here is not enough to bypass the authentication. Currently, whatever headers you are seeing here, not the actual all headers that the host machine is getting. Some headers are not showing here but actually received by the host. To check them, we'll use the trace request instead of get request. Let's try this. If now I send the request, this time if you look at the response that we get, the number of headers we are getting back is more than the number of headers we are sending. Now if you look at the bottom, there is a header named X custom IP authorization. We can use this X custom IP authentication header to bypass the whole authentication. Currently here my own IP address is passed. That's why it is rejecting to get the admin interface. But if we change it to the localhost IP address, then it will may think that the request is coming from any internal network and this is a trusted source and so the admin interface. Now, I'll paste it here. Then type the localhost IP address 127.0.0.1 and I'll again change the request to get and send the request again. And in the response, as you can see, we can successfully access the admin panel from where you can delete the user. Now all this possible, we change the IP address from where the request is going from our own IP address to the local IP address. When the host will get the request, it will think that it is coming from its own local host, which is its internal network, and it will trust the source and show the admin interface to the user. Now to delete the user Carlos, we'll go and check the code. And here to delete Carlos, the path is here available. Let's go and paste it and send the request. I think now the user is deleted. Let's send the get request again to admin. And if you check now, Carlos is deleted and our lab is solved. Now in real world, maybe you don't find this particular header, but you can use that trace method to trace all the headers that the host is getting. After that, from the all the header that you get back, you can choose which one will be helpful for you to bypass the security or get any information that is valuable for you. Now let's go to the last lab, which is in version control history. Information disclosure. Now in this particular lab, we will use the version controller history to find the information. The lab description says that the lab discloses sensitive information via its version control history. To solve this lab, obtain the password for the administrator user, then log into and delete the user Carlos. Let's start the lab. When it is saying version controller, it is most probably the Git version control. There are also some other version controller on the market, but the most popular one is Git. So first of all, we'll start with this. So first of all, we'll try the Git. Now if you're already familiar with Git, then you know where all the changes history is stored, which is on .git folder. First of all, we'll find for .git folder. And this is currently available here, but from here we can't run commands on it and check the logs. We need our Linux machine to clone it. wget-r, then the URL with .git folder. It will copy all the content that is available there to here. Let's move inside the folder. Now if you check inside the folder, there is no file available, but .git file is a hidden file. So you have to use this flag with ls to find it. Currently, if you can see, this is the .git folder. Let's get inside it. And here you can use the git command to check the log. Now in the commit that is made on each commit, you can see remove admin password from config. That means that in this particular commit, the admin password is removed from the config. So we can check it what changes are made between this commit and this commit. For that, we'll use command git diff, then the hash of the last commit, then the hash of the commit that is made before that commit. Paste it, hit enter. And from here you can see what changes are made on admin.conf file. First of all, the admin password was hard-coded, then it is changes to the environment variable. Now we get the admin password. You can copy it from here. Go back to the lab. Now let's log in as administrator. Paste the password. Then we have to log in as the administrator. Hit login. We are successfully inside the admin's account. We can delete the user Carlos. And we successfully deleted the user Carlos from the admin panel. So that's it for this video. The main motto of this video is to show you how you can actually find it. Starting of the video, I tried my best to tell you how you can discover it. And let me know on the comment section on which topic you want to see the next video.